those are the types of things you start worrying about.
If it's easy to read, it's easy to understand what you need to do next.
After you've tested something, you don't want it to take up space.
Hey, welcome to Dad Better. Today we have a really fun episode. One, I'm wearing pink beats because I forgot my headphones at home. Thanks, Alyssa. And two, we're going to talk about bad code. This is something that's near and dear to my heart. I know the definition of bad code can be, very flexible depending on who looks at it, especially if you're a consultant, right? Because everybody's code except for yours is bad. But we're going to actually talk about that too. So with me today, I have two of my amazing software engineers. Introduce yourselves. Jeremy Wood.
Yeah, I'm Jeremy Wood, staff software engineer at 7Factor, and I've always been passionate about writing clean code. Well, ever since at least I read the book Clean Code, great book.
Yes,
and it's it means so much because it really makes a difference.
It does for sure. Maharshi.
Yeah, I'm Maharshi Dubasi. I'm just a regular software engineer here at 7Factor. Yeah, like Jay Wood brought up, clean code is something that helps make your code readable. It's something that I'm passionate about. I only read half of the book, so my code is only half clean. So I'm still getting to the full clean part.
You don't give yourself enough credit. You're definitely super valued member of the crew. And I have my laptop here, so if I'm looking down, it's because we have some code that we want to review today, which is something that we don't do often. So let's kind of do a brief monologue on what bad code is. Again, Maharshi and Jeremy mentioned this book, Clean Code by Uncle Bob. It's a fantastic benchmark to help you understand what clean code can be. And back in the day, folks like Kent Beck and Uncle Bob and all of the luminaries that sort of helped craftsmanship, if I may be silly, into our industry, talked about this concept of short, clean code with iterations that produce good quality software. Now fast forward to today, where the name of the game is get stuff out as fast as you can, and who gives a crap about what it looks like. Now, I have to say there are cases where if you're working for a startup and you have venture money and you're almost out of it, it makes sense to try and go as fast as you can to try and get a feature out to prove out that your idea is in fact ready and it is something that the market wants. But I work for a lot of big enterprises. I work for a lot of mid-cap companies and some SMBs that are well-funded. And these are scenarios where I am very passionate and believe very strongly that there's no excuse for not writing good code. And you go on LinkedIn or the Reddit or anywhere and you post anything on the internet about what is clean code or what is good code, what is bad code, you're going to get all kinds of flame wars and 15 different opinions on what the definition of that is. To me, good code is simply this. It's readable, top to bottom, left to right, like a book. It's small functional pieces that make sense to you when you look at them, and it's very well tested and thought through about, from a feature perspective, these tests make sure to exercise all of the legs of that particular feature, and you're not playing silly tricks like doing public functions to test private functions. I want to go around the room real quick because I think this is, again, as I said, a very divisive topic and people have a lot of different ideas. So, Jeremy Wood, what is the definition of good code in your brain?
Well, honestly, you took a lot of the words I would have used. So I think, the readable left to right, top to bottom is a really good one, in particular because being readable, readable code is really important because you're going to be reading code more often than you're writing it.
Right.
And that's going to make it more maintainable. If it's easy to read, right, it's easy to understand what you need to do next. So clean code is maintainable code.
100%. Yeah. And Maharshi, what do you think?
So for me, it's communication is super important. And so when you have code that is readable, like Jay Wood was saying, if you're pairing with somebody else, it's super easy to explain what's going on. And it's faster to get to a point where you have good working code that, like Jay Wood said, is maintained easier.
100%. And so I'm on a crusade in my industry to try and push people towards writing good code. And that's what 7-Factor is all about, is finding engineers that want to write good code. And again, we have to get things done on a deadline and all that. That's all normal and fine and good. But I actually believe, and this is my next question for you two gentlemen, I think that you can write good code quickly, right? And I think that starts with ensuring that the test that you're building, or the test suite, or however you're deciding to bake quality into the piece that you're creating, it starts there, because that drives you towards making better decisions if you know how to write tests properly. So do you all believe that clean code is slower code, or do you think that you can write code that's clean and well built quickly? What do you think, Maharshi?
I would say absolutely. You were talking about testing. Having a good test suite, doing test-driven development more than likely guarantees clean code. Sure, you might have some redundancies here and there that you can work out toward the end, but having that good baseline will guarantee good code almost every time.
Yeah, and I think you mentioned TDD. Like, people forget the refactor part of the red-green loop, right? Mm-hmm. The refactor piece to me is where that's where you focus on that clean code piece. What do you think, Jeremy? Do you think clean code is slower or faster or same?
Oh, well, that's a tricky topic, and there's going to be a lot of people that disagree there, especially if you talk to like game developers, because they're more focused on the fastest thing often.
100%.
But yeah, I think if you're writing good tests, like you said, the refactor step, that's really important. Fearless refactoring, like write the tests, implement to make the test pass, and it doesn't matter how that first implementation goes, but you're not done there. So you're going to do, you're going to refactor and keep that red-green cycle going,
right,
and get good code as a result.
So you mentioned game development. I think that's another show, because I go on record with Keith Shaw over at Tech Talk talking. I think that modern development does not jive with game development. Like, these things that we're learning about go fast and take iterations. I think Diablo 4 is a great example of they shipped a half-ass game, or at least that's what everybody thinks. To them, it's actually quite good. Like, they've done a lot of cool things. They're reusing a lot of features. From a software engineer, seeing some of the things that they're doing sort of points to the fact that they were smart about their software design. But people out there that want a fully working game are like, I'm just going to go play Path of Exile because this is dumb. But that's a totally different ranting topic. So let's jump into some examples. I want to talk about bad code, right? And if your code is shown on this show, I apologize, but I don't, because you should be writing better code. First example comes from our director of engineering, Alan. I hope this isn't his code. If it is, he's in trouble. But let's take a look at this class. This is C#, and we're going to have different languages here, by the way, because we're polyglots and we don't really care about what languages we work in. So let's give this a look. So we have a namespace, which is an interesting namespace. Oh, by the way, the names may be changed to protect the innocent on these classes. So we're not particularly going to discuss naming except where it makes sense on a general a piece of code. The first thing that jumps out at you on this one, let's go to Maharshi. What do you think about this code?
So the first thing that I'm seeing, it's just all strings except for the address. The account ID is a string. The secondary account number is a string, both of which have number and ID in the name, which should automatically be like, oh, that's an int, right? Or a long, maybe, in some world. So yeah, this is a
pet peeve of mine. I ran into this a lot in some legacy code that I inherited from offshore at a certain retailer I used to work at. And I remember going through the code, and I've always been kind of a database guy where I've wanted my tables to match my semantic layer or my objects that I'm building. And I would see this where like an account number would be a string. And I think some of the history of this comes from like the older school systems, so like your AS400s or sort of the older world, the Fortrans and the COBOLs, COBOL rather, where I think maybe people were just encouraged to use strings for this for some reason, maybe because of bit width. I have no clue. But to me, this is dumb because I can't do proper sorting efficiently on this object, right? If you were to hand me this object and say, okay, I have 100 million of these guys and I want to sort them based on account number, you're going to be sorting strings, which by the way is much slower than sorting an int, right? What do you think, Jay Wood? I think we kind of beat it to death, but is there anything else you see here that's weird?
Yeah, so these are all public properties of this class, and
I didn't even see that. Yeah.
Notably,
Whoa.
the secondary account number, secondary account, all the secondary stuff, for whatever reason, has a lowercase first letter, which being public and property should, probably be uppercase. And also, for whatever reason, they didn't include the getter and setter. So really, it's just a consistency thing. Never like to see inconsistent code standards. It just, I mean, even if you can read it, it's going to just throw you off. And you don't want that when you're reading through code.
Right. And C# publics always have a cap on the first. I didn't actually notice that they were public. Which, by the way, this is a power of code review. I think, brief aside, what we're kind of doing here is live code reviewing. This is how we execute and operate in our teams. As we sit on, we talk about what's going on, and this is a great way for you to get your teams efficient and thinking about good code, because Jeremy just noticed something that I didn't, right? I was just kind of blazing through this and saying, oh, I'm pissed because there's strings. But in fact, there's a lot of consistency issues with this code, right? Even down to how you might serialize and deserialize that to an object model, depending on, if you're using Entity Framework, this would be a lot easier to map these fields. But this could turn into a real nightmare from a consistency perspective. So that's actually a really good thing. Another awkward thing here that I don't like, and people can throw rocks at me, I hate comments. I know for a very long time, people are like, oh, comment your code, and all these nice, pretty Java docs. I used to obsess over Java doc and whatever the C# equivalent is called, XML doc or something. I spent and wasted so much of my life just making sure that the damn comments were in line. And then I come in and refactor something and have to rewrite the whole damn comment. So it's, to me, the inconsistency here about some of these things are commented and some of them are not. And, the top one, the public string account ID, has summary, text, summary, and then the rest of them is kind of all one line. Like, there's a ton of inconsistency there that normally you're thinking, well, it doesn't matter. Well, it kind of does. I would just blow all of those comments away. What do you guys think? Do you have opinions on comments, or is that a hot take?
I would agree. If your code is readable, you shouldn't really need to comment it a whole lot. If there's a lot of complex logic going on that's unavoidable, then having a comment, will help. But in this case, like, take the first thing, for instance, string account ID, a unique identifier of the account. That's kind of redundant. That makes, it's an account ID.
Yeah.
And then same thing with the other two, the account type, the type of account, the status of the account,
Right.
So.
And that's a lot of code generators. Go ahead. Sorry.
I could go either way on whether these, you comment things like this with documentation comments, just because, a lot of IDEs have tools that let you see the docs from a distance, more or less, without having to go into the class and inspect things. But these are pretty self-explanatory names. Status is not necessarily.
Especially because that's a string, right? Status is a string, so I have no idea what that is.
Yeah, you have
I
no
would
idea
normally
what
expect
that
that
is.
to be like an enum or something that has a baseline set of statuses that I care about, right?
But the comment doesn't make it any more clear. So,
Right. The status of the
just get rid of it. This comment's not helping. Yeah. But if you're going to use them, they should be on all of the things. Like
100%.
It's just a consistency thing.
One thing that I don't see here that I normally see in a lot of C# code, and all of the C# people are going to flame me and throw rocks, but I don't care, is account extends I account. Like in C#, back when I worked at Microsoft, the thing to do was every gosh dang flipping class had an interface, and I don't even care if it was like a DTO in JavaSpeak, or I don't remember what they're called in C#. It's been a while, but a data object. Everything implemented a flipping interface, and I think that is just an oversimplification of what interfaces are supposed to be for. But so at least we're not doing that here. But I'm going to attack that directly. C# people, stop interfacing everything. It makes no sense. The Java people have you beat on how to properly do that.
Don't ask me to bring up an old example of my code with the where are the interfaces were everywhere.
I think we might actually, because that's part of the point of the show, right? This video is sponsored by us. To continue our mission of providing valuable educational resources to current and future software engineers and tech professionals, we've officially launched the Dev Better newsletter. Our monthly newsletter will bring highlights of the tech industry right to your inbox at the end of every month. Within each Dev Better newsletter, you'll find the top tech news stories, job postings that we believe are worth your time, and more importantly, development tips for your ever-growing knowledge base. If you think this is something you'd read, we've left a link in the description for you to subscribe for free. Now let's get back to the video. So Maharshi, the next example is something you have. Tell us about it.
So this is an example of a database with duplicated tables. So the first one is the actual table, and the others are test tables. Well, those test tables don't just exist locally. Those exist in dev, RC, and believe it or not, prod.
Okay. And so what irks you about this? And I know we're kind of steering away from code, and we're looking at like the age-old problem of how do you manage development environments. And I have a lot to say on that. So we're having a good conversation here. What specifically bothers you about this? Because I could talk for days, and I don't want to take up all the time.
So after you've tested something, you don't want it to take up space. You know that it's working, get rid of it, especially if it's a duplicate table. And duplicate table, if you're testing it, maybe has like, 1 to 2 things, 3 even. Every duplicate table that you see here has more than 2,000 entries, all of which had to be probably manually entered, or if they had some script running, because there are no like duplicates between the original table and then any of these tables. They all have different data. So if you're not using it, why is it there?
Right. And I mean, you actually mentioned a challenge there too, when there's inconsistency across your testing data sets, which again, this goes into the theory of testing, which is a whole nother show that perhaps we'll do as well, about modern QA and where QA has come from and where they are now. But I've seen this a lot too, where people will archive these tables and they'll just keep them around because, well, I might need them. And it becomes what's called a junk drawer, right? And the junk drawer, a new developer, imagine you're a brand new engineer and you're coming into this particular schema and you're looking, you're like, well, what is that? Like, why is that even there? What does that do? And you don't have anybody to explain to you because everybody's busy. That's normal in engineering, right? Is nobody's going to take 20 minutes to explain that, oh, that's just testing data. And you kind of dig in and you spend hours of your life trying to figure out what the hell these tables are. And all of a sudden somebody tells you, oh, just ignore them. Great, thanks. I just wasted like 2 hours of my life reading garbage that I don't need to see. And this argument extends to code as well, right? And I am a huge fan of delete code. Don't comment it out. Get rid of it. The source control can go dig that back up if you need it one day. And there's no need to just overload an engineer's cognitive existence with garbage that doesn't add value to what they're trying to do.
Absolutely. If you're onboarding a bunch of new engineers, every single one of them is going to run into this problem. Every time 100%. You onboard someone new, they're going to be looking at this and be like, what is this? And if it's like, it just shouldn't be there. It's a waste of time.
Exactly. And the next example, I believe, is a bunch of columns on a table, right, Maharshi? Talk to us about this. This, by the way, makes me have seizures inside. I can't. I would yell at someone, and it would not be nice if I saw this.
So the great part about this is one example from one table, and this exists across all of their tables. And what's great about it is that, A, there's no documentation about any of it. So you're having to go to somebody who was there when this was being built out, or just has prior knowledge of, what it could possibly be. It's just a naming thing. You don't know what it stands for. You can probably assume, but I have assumed something from this table that was entirely wrong. So assumptions are not good for programming.
100%. This is complete garbage. And correct me if I'm wrong, the names of these columns, have they been changed to protect the innocent, or are these actual
These are names? The actual names. Yeah.
Okay.
It's interesting. Given my background, I suspect I know what some of these are, but like most people aren't going to have a background like I do, and they're not going to have any clue what this is.
I have no idea what the hell this is. If you handed this to me, that's why I asked that question, Maharshi. If you gave this to me, I'd be like, did somebody just like obfuscate these table names for no reason? Because I don't know what that is. And I come from like Golang, where it's normal to do var x because that's just what we do in Go. Like for whatever reason, it's sort of just an accepted practice in the community to have terrible variable names. This is complete and utter terror. This is terrorizing, like terrible. It makes me afraid if I had to walk in and understand what these things do. And it also necessitates documentation, right? I'm a fan of make your schemas. And by the way, we don't have to do what we used to do in DB2, where you have like 4 characters for your column names, right? I remember, again, a certain retailer whose logo was orange I worked at that had removed all of the vowels from the variable names on all of the tables because they were in DB2. So we used to make fun of it, and I'm sorry again for those of you who know me at that company. You all are amazing, and you've moved past this terrible point in your history where legitimately we would make fun of and just remove all of the vowels from all of our variables in our classes just to make fun of it, because back then it was a real thing, though. Back then you had to do this because you were constrained in space. But in 2024, where my freaking iPhone is running AI algorithms, we don't have to do this anymore. Yes, it's more typing, but please, for the love of God, write table names and values that make sense so that I can read it and understand what's going on my physical storage layer.
Mm-hmm.
Please don't make me work on a project with a C standard library.
Yeah, oh, you're taking me back. When I was at Georgia Tech, we had to re-implement all of the C functions, and it was great fun. I enjoyed it, but I don't know, some people don't like that. So let's do this one. Jeremy, you've got a good one, and this is actually from a personal project of yours from a long time ago, so I'm actually very excited about this. So this is kind of a long one, so maybe first give us a general, like, what you were trying to do, and then let's talk through it.
Gosh. Well, like case in point, I don't know what I was trying to do here. This is at least 13 years old. My very first Java project. There's a function on line 263 called process data in a class called web interface. So, I mean, your guess is probably as good as mine, at this point. And that's the problem, is that I can't look at this and tell you what this method's for. It's just process data. It takes in a socket and a string of JSON.
Wow.
The first thing that struck me about this, besides the name of the function, was on line 266, there's a try block. And I'm just like scanning down, and I don't see the end of this try block. It's not until, let's see, line
I think 424.
460. So,
460.
like 200 lines later, close this try block, which, that's just don't do that. You don't know what you're catching here with a try catch like this. And, I'm going to plead the fifth on this, perhaps being my first Java project. But yeah, lots of things wrong. You want to take a stab at it?
To you. I will. I'm going to be nice to you for sure, because I have code like this that's floating out in the. Just go check out my GitHub for some of my older projects, and I'm sure I have like way worse than this. Something I find interesting here is that on line 268 you call next token, 275 you call next token, 277 you call next token, 279 you call next token, like. You're basically, and you're unrolling a loop, right? So you're manually, but this is the thing. This is how you thought about it. Like going back to 13 years ago, Jeremy Wood, I guarantee you were sitting there going, man, I just need to get the next token. And this is what I need to do with that one. And then I need to get the next one, and I got to do this with that one, and so on and so forth. And so I think what you didn't know back then was refactoring, because you solved the problem and it worked, and you're like, cool, I'm good, moving on with my life. And I've solved problems like this where it's a very chunky, difficult, iterative, go to A, B, C, D, F, G, walk the graph type problem. Visitor pattern is a very complex way to solve the problem, right? But there's good ways to do this that are cleaner. But I don't think that, I think you were just solving the problem. This is a trap a lot of engineers fall into, is you solve the problem, but you don't come back and say, well, is there a cleaner way to solve the problem? Like, I know what I'm doing. It works. But now, can I modify this so that it looks nicer and it's easier to understand what's going on? Because I can read top to bottom, left to right, and kind of see what you're doing here.
I think one of the things
that
you were talking about, how engineers don't go back and refactor. If it's something that was ridiculously hard to accomplish in the first place, you might not be inclined to go back because you're like, oh, I don't want to deal with it being so annoying.
Right.
So, yeah.
The things I was concerned about at this point in my career path was indentation. So I'm sure the indentation's correct in here. But it's like
spaces or tabs, right?
Yeah.
Spaces or tabs, Jeremy.
At least the right number of either one,
Right. No, I need to know spaces or tabs. This is flame wars in the comments.
Definitely spaces.
I am 100% agreement with you. Maharshi, are you tab person?
I'm a tab person, yeah.
That's because you write Python, right? Python's terrible. Again, fight me in the comments. I hate Python. Significant white space shouldn't exist. No, that's awesome. And so just looking through more, like there's a password equals here. So you got a double if and then an else and then a return. So this is actually an anti-pattern that I want to talk about, that I've gotten in trouble for doing this when I've done this in past lives. But I think there's a time where it makes sense to use a return to break out of a particular function. But if you use like the small function approach, something I think would be difficult here would be figuring out what is the proper function where you're doing those returns, because you do a return on line 273, you do another return on line 288, and then you do another return on line 295, and then I'm trying to look for other ones. So if I'm working on this code and I'm trying to understand when does this function exit, oh, your last return is on line 470. So if I'm trying to understand when does this code exit, it becomes very difficult for me to track in my brain, right? So if I were code reviewing this, one of the first things I would say, and you as well, is let's break this into smaller pieces so that we can get our hand around the control flow a little bit better, right? Because control flow is a thing that a lot of engineers struggle with. They have a hard time figuring out when to return things. Should I return null? Should I throw an exception? Java is notorious with the throws stuff, which, by the way, the one massive critique I have with Java is throws. I hate it. I get why you do it, but it's really sort of annoying. But I think that is one of the big pieces here that I would find a lot of engineers to struggle with, is when do we return? When do we align, the object that I'm sort of mutating? Because, by the way, you are mutating an object and returning it, which is also another thing that you probably shouldn't be doing. So, again, refactoring, right, is a thing that you would do here to kind of make this better. So, actually, we're kind of running out of time here. So, I want to give each of you one more swipe at this. What are some other things that you might consider changing here that are sort of general anti-patterns you've run into in your life?
There's a lot of if, else, if, else, if, else. There's a bunch of these on line 298, 305, 325. Even 398 goes all the way down to there. 412. All these, it's all just testing the same string, and whether it equals something. So obviously, this is a place where you use a switch case, but I mean, each of these things within these blocks, you're talking about breaking it up. That's the perfect point. If you stick with the if and if else if, like, at least break up the bodies of these into separate methods, because then you can see all the cases at once. Like, you have to scroll down to see all these cases, and that's no good.
Right. And having good names for each of those breakpoints is important, right? So that the function has a job that makes sense. So, Maharshi, what do you think in closing? What are some things that what are some code review notes that you would leave on this particularly massive function?
So the first thing that I see is how he's comparing strings within the request. I would switch those to be something constant, as opposed to being just a random string. And then the other thing is, like you said, just move things out to methods. Some of these could be its own different class that you can call into. So that way you have kind of a barrier, and it's easier to read the entire thing.
You also have some commented code on 445. Shame on you.
Oh, there's comments all over. 297, 304, 311.
Yeah. No, I'm talking about you comment out.
Oh, commented out.
Yeah. No, and so on that note, though, I want to take a brief aside here, and then we'll wrap it up. So there's also this propensity to over-optimize these types of things. So like the equals ignore case in Java is actually quite fast, and it's very good at figuring out, for some arbitrary string. I forget the complexity of it, but I remember studying it in school and spending time with the open source code. It's pretty quick on figuring out if something is equal to one another. But to Maharshi's point, if you were to convert that over to something like an enum, right, that's an int, and you take your hit on the deserialization side, or if it's an object coming in, right, you have it as JSON here, right? So I would even say, why isn't that an object? Like, why are we manually testing a string for something that could probably be serialized into an object in memory that's going to be orders of magnitude faster than sort of walking through this giant JSON, despite the fact that the tokenizer for Java is quite fast. It's a very mature, it's been around for a long time. People have done a lot of really good work on it to make it go pretty quick, but that would be even faster if you're doing in-memory object level access, right? Where you're saying, oh, let me go do that and do this. And again, I highly doubt that matters in your particular thing, because again, I don't want to over optimize this, but if this were like in a game or a real-time data loop or something where I'm calling this hundreds of thousands of times per minute, then those are the types of things you start worrying about, and you start thinking about, Quake fast square root. They did some crazy shit, but it's super, super fast. Nobody knows what it does. I mean, yes, there are YouTube videos you can watch that'll tell you how it works. But my point is that your average engineer is like, I have no idea what that does, and I don't need to know because it just works. So, hey, guys, thank you for doing this. If y'all like this, please comment, subscribe, let us know. I love doing these kinds of things. I think it's exciting and fun to talk about in the trenches with some of our amazing software engineers, the things that we've run into. But if you like this, comment, subscribe. We'll do more of these. Maharshi, Jay Wood, appreciate you guys for coming on, and especially you, Jeremy. Thanks for giving some of your own code. We'll leave a link in the description for some things. You can go look at this stuff, and we appreciate everybody's time. Have a good day.